Good morning to everybody. My name is Luca Ronchini. I'm responsible for the cybersecurity team of Thales Italy for the Airport Competence Center located in Florence. The presentation that we will show you is based, will show you how Thales protect critical systems of an airport environment from cybersecurity attack in order to manage and minimize potential impact and damages. The scenario that we will show you is based on a denial of service attack with the WannaCry ransomware to a boarding pass check control system that is one of the most critical systems in an airport environment. So, as you can view in these slides, the airport environment is a very critical environment populated by a lot of different systems. Critical, for example, physical security systems or data center IT systems or communication systems and so on. In this environment, that is, it's to protect this kind of environment that is critical and with a high level of complexity, we need to develop a new kind of airport security approach. Thales is able to solve this kind of problems, to protect this kind of system because knows well both the aspects. Thales is leader in cybersecurity because with our solutions and services, and also is leader to implement this kind of environment. So knows both the element. We are able to have a new vision of airport cybersecurity, and what we will show you is a cybersecurity system that is able to correlate logical events coming from cybersecurity attacks and physical events coming from this kind of environment. The correlation between the two elements, two environments, will produce specific alerts that can be sent to the operational activity and help airport operation to manage a crisis coming from a cybersecurity attack to critical systems and mitigate potential impact and damages on this kind of critical assets. The boarding control system is critical because it's an operation and security system. It is responsible for example, for the security check of passengers. And my colleague, Stefano Cigari, that is a system engineer, will show you what happens when this kind of system is under attack of cybersecurity attacks. As you can see by this kind of slides, all the system, the operation activity of the system is managed by a Thales Airport Operation Control Center application that is a vertical supervisor that integrates all the system of an airport environment. And this is the element that we cooperate and is integrated with the cybersecurity system, and that will receive the alerts from cybersecurity systems. Just an information about Thales AUCC. Thales AUCC is the system that is able to manage the smart security of an airport environment, physical security and cyber security. Is responsible of total airport management. This is operational activity of the airport, and is responsible for the password management. It means the security and the flow management of the passwords in the airport. With Thales integration firm, all the systems, for example, airport IT, air traffic management, cybersecurity and so on, are integrated. The correlation between the Thales cybersecurity system is managed by an infrastructure that composed by a network detection engine with the Thales cyber sensor. In another stand, you can view a demonstration about the capabilities of these technologies. a host, that is responsible for the management of attacks on the network, a host intrusion detection, Thales, that is responsible for detect attacks on specific systems, for example, a Windows server, and a remediation solution that is Thales Varmetry, that is a data protection systems. In this scenario, the scenario of ransomware WannaCry, is critical because WannaCry is a malware that encrypts the file system of a server. So encrypting a file system, the file system compromised is not able to run. So in this case, we use a data protection system that permits to manage the access to the file system and avoid that a malicious activity try to encrypt the file system itself. What we will show you is an activity of detection, analysis, and remediation of the attack. And the final goal is to perform, to send alarm correlation and feeding to a OCC operation system. Stefano will show you now what happened when a WannaCry malware attacks border pass control system.
So this is the Airport Operation Control Center. This is a representation of what the airport operator in the control room will have in front of his view. Basically, as you can see here, the operator is able to visualize, for example, the passenger terminal building map with all the resources and devices that are integrated. We have chosen this area for the scenario demonstration, that is the border control area at the passenger terminal building. As you can see, there are some queues here that will be populated by the queue detection system that continuously is checking the situation and sending the waiting time based on the people present in the queue. In the first scenario, we have basically an attack to the queue detection, to the boarding pass control system, and we have no integration with the cybersecurity system. So in this case, what happens is that basically all the waiting time at this queue will start to increase because of the people present in the queues. The system is under attack, but the operator in the control room is not aware of this attack because there is not integration with the cybersecurity system. So if I move here, for example, on the indicators panel and start to visualize, for example, the waiting time at the queues, at first, as you can see, we have Q1 and Q2. Just a moment, okay. Q1 and Q2, that are these two queues here that start increasing because people arrive, but the operators of the BPCS on the field are not able to serve them well because of the cyber attack. So the BPCS server becomes irresponsive. They are not able to scan the boarding card of the passenger and to allow them to enter to the area. What happens is that when the waiting time of the people in queue exceed the defined threshold that here we have set to 20 minutes, basically the queue detection system will send to the AOCC an alarm to inform that the queue waiting time is too long. The operator is able to react to this alarm, but is not aware of the attack to the BPCS. So the only thing that they can do is to open, for example, two more lines, the Q3 and Q4. So for example, here I receive the alarm. I can acknowledge the alarm and manage the procedure. The procedure, say for example, to open two more lines and to send operator to serve these queues. So what will happen is that people will be redirected from Q1 and 2 to Q3 and 4. But passing the time, also this queue will start to increase because the system, the BPCS, is not working. So this is, let's say, the worst scenario that we may have, in which basically the operators try to, let's say, rearrange the passenger to the queues, to the resource that they have available at that time, but they are not able to detect and manage the real issue that is the attack at the EPCS system. So now Luca will explain how we can solve this type of attack, and then we will have another scenario that will show how things may go different.
Sorry.
Yeah.
So the operator still doesn't know that
The
he's
operator
under
doesn't
attack.
know. This is the first scenario in which we don't have integration with the cybersecurity system. So the operator doesn't know. He only sees that queues are going too long and try to use other queues to serve people. But the system, the BPCS system, is not working. So as you can see, the situation is really bad.
Yes, the potential impact of this kind of situation is, for example, a delay in flight boarding activity, delay from flight departure, but also it is possible to have an impact on the security of the passengers inside the airport. So, as you know, WannaCry is a malware very used in the attacks of critical infrastructure. Just 2 weeks ago, a big player in the USA of airspace industry was affected by this kind of attack. WannaCry is a new generation of ransomware that, with new capabilities, for example, to replicate itself on the network, and this is very, very, very dangerous. So, what the new approach of Thales of airport cybersecurity is doing to solve this kind of situation? This is a situation where we have specific sensors that are working on the network and at system level, just to detect some suspicious activities. The first detection is related to a high level of logon failures on username with bad password. This could be normal in a situation where a user is not an administrator user. The WannaCry payload starts with an attempt to obtain administrator privileges to compromise the system. And this is what we are detecting. For example, in this very short time, there is a lot of malicious activities, logon failure, and is related to a specific user. Sorry. Oh my God. Administrator users are involved in this kind of strange situation, and in specific, there are two servers, boarding pass control system Prime 1 and 2, that are under attack. This is the situation where we start. The second activity is at the network level, because our sensor detected a specific attack. And there are two indicators. There are an attempted administrator privilege gain. That is the first step of the attack. I try to impersonate the administrator to compromise the servers. And then there is an exploit. An exploit is the technique to violate the systems under attack, named Eternal Blue, that is specific for WannaCry ransomware. And this is the detection that means that we are under attack with WannaCry ransomware. What the system is doing what the cybersecurity system is doing at the moment, it produces different kind of alerts specific that are sent to the AOCC system to permit to the operation activity to be aware, first of all, that that kind of problem is related to a cybersecurity attack. And the second alert, and this is Eternal Blue attack detection, and the second specific alarm is that we have detected that the attack is WannaCry attack. WannaCry attack produce a potential impact on the file system of the server because it tries to encrypt the file system. and don't permit to the server to work. And this is why we are approaching the first level of remediation with Thales Vormetric. Vormetric is, as I said before, is a data protection system that don't permit to WannaCry engine to encrypt the data, because block the right activity of the system. So in this case, there is a third level of alert that will be correlated with the other two and produce a high level of alert for the AOCC that help the operation activity to be aware of the situation and apply the right security operation procedure to manage the crisis and mitigate the impact and the damages of this kind of attack. This is what the cybersecurity system is doing for the operation activity of the airport. This engine of correlation is the new approach of airport cybersecurity that is developed by Thales. So we are able to detect, analyze, and produce a first level of remediation that block the attack. The airport operation is aware of this and will apply the right procedure. And now, and after, and during this time, the cybersecurity team will remediate the situation with the right procedure. For example, switch to disaster recovery if a system is compromised, and isolate the attack and solve the situation. This is what happened after we sent the alarms to the AOCC platform.
I was going to say, this must be an example of how your 0 day is working to prevent unknown attacks, because any airport that would still be attacked by WannaCry should have their CIO sacked.
Yeah.
And WannaCry is old.
Yeah, WannaCry is simple and an example. This is a simulation of unknown attacks, or is possible, and you can start the remediation. You will see that the system is connected with Wi-Fi to the AOCC and is sending the alarms to the system. Now I'll give you an explanation and some more details. WannaCry is only an example. Okay, it's a very known attack. New development of WannaCry are very dangerous in this kind of situation. WannaCry is detected by a malware solution, but there are some situations where this is not completely true. For example, our customer has apply a bad policy for technician that works outside the secure perimeter, and permit them to be administrator of a laptop. And normally what happens is that they work outside the perimeter. The anti-malware is disabled. They use for personal activity the system and return with the laptop infected. WannaCry is able to encrypt local folders, but also shared folder on the system. And this kind of attack is not detected by a malware solution. And this is why, because we are able to intercept the malware at system level, even if a malware solution is not able to intercept or don't detect because disable the infection and the attack. Is a real situation that we have solved.
I start the second scenario. Basically here we have the same environment of the first scenario, but this time the airport is protected with the Thales Cybersecurity solution. So what we can see this time is that again the queue within time started to increase, but this time when the BPCS system will go under attack, basically the cybersecurity solution will be able to detect it and to react against the attack, and to send to the operator in the control room an alert that the operator will be able to manage. So basically, just a moment, because okay. Meanwhile, I continue to tell the story. Basically, what we can see, what we will see is that again the queues will start to increase, but as the attack is being detected by the cybersecurity system, these queues will remain under the threshold of 20 minutes that we have defined. And the BPCS systems, the cybersecurity system, as you can see, sends a message that the attack has been detected. And this time the operator has a procedure that allows him to switch to manual mode just to be sure that there will be no impact on the BPCS system, and to open again 2 more lines. What has changed with respect to the before scenario is that this time the alarm that I receive here is sent directly by the cybersecurity system that informs the operator that the BPCS is under attack. So because of this, the operator decides to go to manual mode instead of being to automatic mode, just to be sure that, let's say, the waiting time will be managed properly, and to open 2 more lines. Once, let's say, the attack will be solved by the cybersecurity system, the operator will receive another notification that the BPCS system is again safe and is back to normal. Again, here I can show you the waiting time for the queues, and as you can see, for example, here we have the first 2 queues that had this peak when there was the attack. Then the operator went to manual mode and opened it Q3 and 4, so the people were redirected. And the situation was managed by the BPCS guys on the field. Meanwhile, the cybersecurity guys will solve the attack. And after the attack has been solved, another notification arrived to the system that informed the operator that the BPCS is safe again. And again, he can start the recovery procedures to come back to the original situation, in which the BPCS goes to automatic mode, and we close the 2 lines that were opened before, distributing the people from Q3 and 4 to Q1 and 2.
Yes, we have to change groups then. Thank you.
Thank you very much for your attention.